In mid-1989, the Voyager spacecraft sent back their last pictures from space. The photos of Neptune were captured after a 2 billion-mile journey through the solar system, as Voyager went towards interstellar space far beyond Pluto. Originally, there were 2 Voyager probes, designed and built only to go to Jupiter and Saturn, to photograph these 2 planets and their moons. Only later was it developed to have one of these probes pass by Uranus in 1986 and Neptune in 1989, which far exceeded the capabilities of the probe's computer system and radio transmitters. There almost wasn't a look at Uranus or Neptune. As the mission was originally conceived, 2 spacecraft would have taken advantage of a rare planetary alignment and toured the 4 giant planets in the outer solar system. The Grand Tour trajectory was discovered about 1965. There was an opportunity, which turned out just to happen only once every 175 years, for a spacecraft to go to Jupiter, to be slingshotted by Jupiter's gravity to Saturn, to be slingshotted from Saturn to Uranus, and eventually from Uranus to Neptune. Launched within weeks of each other in 1977, the twin spacecraft parted company after the Saturn encounter. Only Voyager 2 could catch the cosmic wave that would take it to Uranus and Neptune on a bargain basement version of the Grand Tour. But there were problems ahead. The fact that Voyager 2 was able to transmit pictures from Neptune is a miracle of engineering. The geriatric spacecraft's computer suffered memory loss, and its command receiver was tone deaf. So weak were the signals it sent back, the network of ground antennae was enlarged to catch the spacecraft's whispers from space. Despite the difficulties, Voyager has sent back extraordinary postcards from other worlds to its family on Earth. Remember the images from Jupiter and its moon, Io, where 8 active volcanoes were photographed. Two years later, Saturn came into view. Voyager glided through its spectacular rings, snapping pictures that have helped scientists understand the ring's origin and composition. In 1986, nearly 2 billion miles into its journey, Voyager arrived at Uranus. It photographed the planet's surface, dark rings and moons. In many ways, its largest moon, Miranda, with its rocky contours, cliffs and canyons, stole the show. Voyager's encounter with Neptune provided a wealth of data for scientists at NASA's Jet Propulsion Laboratory. They've concluded that Neptune is indeed a gaseous planet with 3 complete rings. Neptune is a very beautiful blue colour because of the methane in its atmosphere. The gaseous methane absorbs red sunlight preferentially, so the light which is reflected back looks blue-green. A beautiful blue-green colour superimposed on high white cirrus clouds, which are probably methane ice, freezing up at the base of the stratosphere, giving a very ethereal-looking planet. Swirling across its surface are winds of over 1,000 kilometres an hour that appear in photographs as large dark spots. Voyager also discovered 6 new moons within Neptune's orbit and provided images of the surface of Triton. We found that the surface is only 37 degrees Celsius above absolute zero. Now that's cold. The coldest surface we've seen in the solar system, so cold that the nitrogen is mostly frozen, as is the methane. You might expect such an unusual surface to have unusual geology on it, and indeed it does. Some features remind us of Mars, others remind us of Europa. Some look like Io, and others like Ganymede. So on this one small moon, there's a huge diversity of geological structures. Following the Neptune encounter, Voyager will continue to send back data as it ventures beyond the solar system. Scientists who expect to track the spacecraft for an additional 25 years hope it can also provide information about the interstellar medium. But Voyager 2 has already earned its place in the Space Explorers Hall of Fame.